You are welcome back to Ashelebe Latifat Online Academy. So in today's class, we want to solve some questions on GP and AP, and those questions are Waec questions. So happy viewing, let's solve it. They're the 5th, 9th, and 16th terms of a linear sequence. So arithmetic progression is also known as linear sequence. Are consecutive terms of an exponential sequence. So exponential sequence is the same thing as geometric progression. Now find the common difference of the linear sequence in terms of the first term. 2. Show that the 21st, 37th, and 65th terms of the linear sequence are consecutive terms of an exponential whose common ratio is 7/4. Solution. The 5th term of an AP. So the nth term of AP is equal to A plus n minus 1d. Where A is the first term, n is the number of terms, and d is the common difference. We have done that. The 5th term of an AP can be written as the 5th term is equal to A plus 4d, and the 9th term can be written as A plus 8d, and the 16th term can be written as T subscript 16 is equal to A plus 15d. So our consecutive terms of an exponential sequence, that is GP. So we can now say, let's write them in sequence form. A plus 4d, so that will be the first term of the GP. Then A plus 8d, that's the second term of that GP. Then A plus 15d. So now find the common difference of the linear sequence in terms of the first term. So the first thing is that we need to find the common ratio. So to find common ratio is small letter r. It will be the second term divided by the first term. A plus 8d over A plus 4d. And also, common difference is still the third term divided by the second term is equal to A plus 15d divided by A plus 8d. So we can now say, therefore, A plus 8d. So we want to equate the two equations together. A plus 8d over A plus 4d is equal to A plus 15d over A plus 8d. So cross multiplying gives now be equal to A plus 8d multiplied by A plus 8d is equal to A plus 15d multiplied by A plus 4d. So let's do the expansion. A multiplied by A squared. A multiplied by plus 8d plus 8ad plus 8d multiplied by A plus 8ad plus 8d multiplied by plus 8d gives plus 64d squared is equal to A multiplied by A here also gives A squared. A multiplied by 4d is equal to 4ad plus 15d multiplied by A gives plus 15ad, and plus 15d multiplied by 4d gives plus 60d squared. A squared plus 8ad plus 8ad gives 16ad plus 64d squared is equal to A squared plus 4ad plus 15ad gives plus 19ad plus 60d d squared. Now let's collect like terms. So a squared minus a squared plus 16ad minus 19ad plus 64d squared minus 60d squared. Everything is equal to 0. So here positive a we cancel negative a. Positive a squared we cancel negative a squared. So we are left with plus 16ad minus 19ad gives minus 3ad. Then plus 64d squared minus 60d squared gives plus 4d squared is equal to 0. So we can see that they both have d. So we can factorize d out. So we have d into bracket minus 3a plus 4d. Everything is equal to 0. So here, let's write those numbers inside the brackets. So 4d minus 3a, everything is equal to 0. So we can say that we have 4d minus 3a is equal to 0, or d is equal to 0. 4d minus 3a is equal to 0. So from here, 4d is equal to 3a. So divide both sides by 4 gives 4d divided by 4 over 3a divided by 4. So 4 cancel 4 here, so we are left with d is equal to 3a over 4. Now that is the common difference. So the common difference d is equal to 3a divided by 4, because they have to find it in terms of the first term, which is a. So we have solved the first one. Question 2. Show that the 21st, 37th, and 65th terms of the linear sequence, that is AP, are consecutive terms of an exponential sequence, that is GP, whose ratio is 7 over 4. So solution. For AP, the nth term for AP is equal to a plus n minus 1 multiplied by d. So the 21st term will now be equal to a plus 20d, and the 37th term will be equal to a plus 36d, and the 65th term will be equal to a plus 64d. And recall that we have gotten d to be equal to 3a over 4. So that means wherever we see d here, we are going to substitute the value of d to be equal to 3a over 4. So from here, the 21st term will now be equal to a plus 20 multiplied by 3a over 4. And here also will be a plus 36 multiplied by 3a over 4. And here will be a plus 64 multiplied by 3a over 4. So let's simplify. 4 here 1, 4 here 5, 4 here 1, 4 here 9, 4 here 1, 4 here 16. So the 21st term will be equal to a plus 5 times 3a, 15a. 37th term will be equal to a plus 9 times 3a, 27a. And 65th term will be equal to a plus 16 times 3, that is 48. 48a. So all these ones, they are now the consecutive terms of an exponential sequence, that is GP. So now be equal to a plus 15a, 16a, followed by the 37th term, which is 28a, and the 65th term, a plus 48a gives 49a. So all these ones, they are now the consecutive terms of an exponential sequence. So the first term will be 16a followed by 28a followed by 49a. So they are in GP. So now we want to show that the common ratio is equal to 7/4. So here, and the common ratio will be the second term, which is 28a, divided by the first term, which is 16a, and also the third term, which is 49a, divided by the second term, which is 28a. So we want to show that whether these numbers are going to give us 7/8. So here, a cancel a. What do they have in common? 4. 4 in 16, 4. 4 in 28, 7. So, and here also, the common ratio is still the same thing as the third term divided by the second term, which is 49a divided by 28a. So here a cancel a, and here 7 in 28, 4. 7 in 49, 7. So that means we have proved the question. So till I meet you in the next class, thank you.